Hi, I'm Max from coderonline.de. Today I'm going to show you how encryption works under Linux, and for that I have prepared a device in my virtual machine here. The device is called dev-SDA and can be found using utilities like lsblk. I like it because it's very convenient and brief, and it's very important that you actually get it right, because what follows can destroy everything you have on your disk. So be careful and always double check if you have chosen the right device. After this warning, we will start, and I want to introduce the command crypt setup, which can be used with a cipher, an action, and how this action gets constructed you have to look up in the manual. The manual of crypt setup says that there are basic commands, open, close, status, and we have these LUX extensions here, which are commonly used nowadays. We're gonna start with this command, which takes the device as an argument. Crypt setup looks format. Dev-SDA would be the command we use to initialize the device SDA to be used as encrypted disk. It asks me if I'm really sure that I want to destroy all data which is on there. After confirming this, it asks me to enter a passphrase. In this case, I'm going to use a very simple passphrase. And maybe you have seen in the background that after having entered it twice, my file manager has already shown an encrypted device. If I would click on it, it would not work. That is because there's no file system on the device. To get a file system on there, the first thing we must do is to open our newly created device. And for that we are using LUX open, and this wants a device name as an argument and a name. So we might want to call it very encrypted. So we have to re-enter the passphrase we defined before. And after having done that, a new device will appear under dev mapper. This is called after what we have called it before. This is actually the disk which can be formatted using tools from the MKFS series. I have installed these and I am using ext4, let's say. And we have the possibility to label the volume when creating it with the parameter -l, and we are going to apply this on dev mapper very encrypted. This will create our file system, and this will make it possible for the file manager to actually mount the device. That's how most people use LUX, and it's very comfortable. Once you have this device, it will reappear after every reboot, and now as this device is unlocked with this open lock, I could create files on it if I would be allowed to. That I am not allowed to is because I have created the file system being root, and so only root can access the file system. To make the file system accessible by other users as well, you have to set the ownership of the file system, and for this we have to find out where our file system has been mounted. I'm using lsblk again, and this shows me that my file manager has mounted my device to this location. Looking it up, it shows me one folder, lost and found, which is a hidden folder, so to say. It's not showing up in the file manager. Using ls-la, I also see that this folder is owned by the user root, and I can use chown to reassign this folder to another user and group. And this is a username, and this is a group name I want to assign it to. And again, I can use this path, and this device now belongs to user Max. So that user Max would normally be able to create folders now, but a file manager hasn't recognized the change yet. And we have to leave and re-enter the folder. So now it's possible to create a test folder inside our encrypted device, unmount our device, remount our device. Very nice to use, actually. In the second part of this video, we're gonna talk about what's not so nice about it, and we will consider some applications where you can use it and where you can't. And I will also tell you why it is better or might be better to use one or the other cipher. Thanks for watching. This was the first part of a series of screencasts concerning encryption with LUKS under Linux.